Alright, welcome to the NUPOC Video Study Guide number 27. Let's look at question 1. Now we're in the graphing section of the math section of Guide 1. And this just asks us to graph x squared plus 2x minus 3 minus y equals 0. So we'll just bring the y to the other side and get in a form that's a little bit more familiar. And so we have this second order polynomial here. So the best way to approach this is to just kind of do some of the analysis that we've done in some of the previous problems in the general section, and that is let's just start by finding the roots and the maxima and minima, and it'll sort of give us some insight into what the graph looks like. So let's go ahead and factor out this polynomial here, and we could use the quadratic formula or completing the square or something, but probably a quicker way to do it is to just do it by inspection, since this is a fairly simple polynomial. So we know we'll have an x in both factors, since we have this x squared out here, and then we want to look at what term or what two numbers would multiply to minus 3 and then add up to minus 2. So that's fairly straightforward. We could have a minus 1 in one of the terms and a plus 3. So 3 minus 1, that'll be positive 2, and then we'll multiply to get minus 3. So we know our roots, or our two values of x that will give us a 0 crossing, a y equals 0 crossing, right, will be x equals minus 3 and x equals plus 1. So let's just go ahead and kind of put those on here, right? So this will be x equals 1, and maybe this over here is x equals minus 3. And so our graph is actually just going to be a multiplication of these two graphs here, actually. So this would be y equals x plus 3, so this would just be y equals x, right? A line with a slope of 1 and a y-intercept of 3. So that would be maybe something like this, right? And this is y equals 3. And then x minus 1, so again, same slope, but with an intercept of minus 1. So maybe that's something like this here. Right? So if we just multiply these two lines together, we would actually get our parabola, and you can see that if we multiply these two lines here, this one is 0, and so we'll get a 0 crossing here and a 0 crossing here. So we know it's going to be, we also know it's going to be open up because of the positive on the x squared term here. So let's just kind of find out where our minima is going to be, somewhere in here. So let's go ahead and just take the derivative. So dy dx, right, it's just going to be 2x plus 2, okay? And we'll just set that equal to 0 and find out where our critical points are. So this will just be 2x equals minus 1, right? And so we'll have x, 2x equals minus 2. So we'll end up with x equals minus 2 over minus 2, minus 2 over 2, which is minus 1. So here at x equals, let's say, minus 1, that's where our critical point is. So what is the value of y at our critical point? Let's just take this and put this back into this equation here. So we'll have y equals minus 1 squared, which will be 1, plus 2 times minus 1, so that'll be minus 2, minus 3. So that will be minus 1 minus 3, that'll be minus 4, right? Or minus 5 plus 1. So this will be down at, I don't know, maybe this is somewhere down here, y equals minus 4, right? So we'll just drop a couple of lines here, right? So that will be our critical point, and just to show that it's going to be a minimum, let's look at dx dy here, just to the left of that critical point. So maybe let's take a value of x equals minus 2. So let's look at dy dx evaluated at x equals minus 2, and we will get 2 times minus 2, which is minus 4, plus 2 equals minus 2. So we have a negative slope, so we're sloping down in this area to the left of our critical point, and then if we just look at dy dx evaluated somewhere to the right of the critical point, so let's say x equals 0, we'll get 2 times 0 plus 2 equals 2 plus 2, right? So we'll have a positive slope, right, to the right of the critical point. So we can go ahead and we can actually just go ahead and graph this now. Sort of do a rough sketch. So we'll come down and we'll cross the x-axis at x equals -3, come down to y equals -4 at x equals -1, and then come back up, crossing the x-axis at x equals 1. So there it is. So just a quick walkthrough of getting the graph of this second order polynomial by finding the roots and then the critical points and determining whether they're a minima or maxima.